All right, so welcome to this lesson on the introduction to quadratic equations. So up until now, all we've ever looked at are linear equations or straight lines, as we typically refer to them. Lines, as a general rule, are considered to be straight, and these are now quadratic equations. Sometimes you'll hear people call them quadratic functions, okay? But I generally like to just say quadratic equation. Okay, so what is a quadratic equation? Well, the word quadratic comes from the word quad, which means square. And all quadratic equations have one variable. There's two variables usually that are one variable that is squared. So for example, you're going to have I'm going to just bring my pen in here and circle some things here. So you're going to have a variable that is squared, i.e. x squared. And the most basic quadratic equation is y equaled x squared. And so I just like to, identify some things, how they look, so that if you look at an equation, you should be able to look at the equation and determine whether it is quadratic or whether it's linear or whether it's actually circular. So I'm going to give you three different types, and we'll just go through some examples here and see how you do. Okay, so if I look at this very first equation, y equals 2x minus 4, you'll see there's an x and there's a y. Neither of these have a square on them. There's no square. So this represents a linear equation. So it's a straight line, okay? And this is exactly what we actually plotted and graphed in our last couple of units. So this would have a y-intercept of -4 and a slope of 2, and this works really good, okay? Now, if I look at this equation, which is very similar, the next one, you'll see that we've now added an x squared. So it's y equals 2x squared minus 4. This is now a quadratic equation. So they're a little different. So we write quadratic right here, okay? And that's in a quadratic equation. And then if I go down a little further, you'll see I have y squared equals x squared minus 4. So if I have both the y and the x squared, this is not quadratic. It's not linear. This is what we refer to as a circular. Okay, a circular equation. So if we were to graph this, it's actually going to kind of come out to be some sort of a circle. Okay, we are not doing those in this course at this time. Okay, it is sometimes studied, but at this time we're not looking at circular equations. Okay, so let's move down and look at some other examples. So here's an example: 2x minus 3y equals 8. Well, are any of these squared? No. So since neither of them are squared, then this is a linear, okay, equation. So pretty straightforward. Then I look at the next one. Y equals 1/4 x squared plus 19. Well, the x is squared, the y is not, so that makes it a quadratic. Sometimes we just get lazy here and just write quad, but technically quadratic is the proper term. And then if I look at the next one, x squared plus y squared equals 16. Now I see both the x and the y are squared, so therefore this is now a circular equation. Okay. And then we get down to the last one, which I kind of like, and it is y equals minus 3x squared plus 2x minus 8. This has an x squared. It also has an x, and then it has a y. So because it has an x squared and the y is not squared, it will qualify as a quadratic. And then we go down a little further here. This one is y equals 3x plus 2. This one does not have a square on either of these, so this would be a linear equation, straight line equation. And then the last one, this is a little bit tricky because I have y equals x minus 2 times x plus 4. And if you recall correctly, we can multiply this through, and when we do, we end up with a x squared. I don't need to know anything else. As soon as I know that that multiplied together is going to be a squared, that is going to give me a quadratic equation. Okay. Now, if you wanted to, quadratic equation. My handwriting with this pen on this white screen is not always the best. I apologize, but bear with me. If I wanted to, I could complete this through. This would be minus 2x plus 4x, so this would end up being plus 2x minus 8. And if I multiplied it all out and using FOIL, so I'd get plus 4x for that one, then I'd get minus 2x. Those two would combine to give me positive 2x, and then at the end I'd get minus 8 right here. Okay, so I just did it in one step, and so this would be the same equation would be y equals x squared plus 2x minus 8. So that's your way of sort of determining whether something's quadratic or not. You should be able to recognize it. Key thing is you have at least an x squared. And I'm going to be honest, we don't use any other letters. I'm not going to use a's or z's or anything like that. It's always going to be y, and it's always going to be the x that is squared, okay? That's just to keep things simple. Now, I want to graph the most simple, the most basic quadratic equation. It's really important that we do this and we take our time and work our way through it. And so what we do is I've created a series of values for x, and here's my equation, y equals x squared. This is what I'm going to try and graph, okay? And we're going to use the table of values method. So you might recall that in that case, we pick values for x, and we calculate what y is. So let's say, for example, I'm going to choose the value of 0, okay? And I'm going to put it into the equation. That would become like y equals 0 squared. Well, what's 0 times 0? Well, that's 0. And so I have a point now here. This represents the point 0, comma 0. And I can plot that point. So I'm going to scroll down. You have your page in front of you. I can scroll down. I'm going to plot that on here. So, well, hang on. I got to do a few things here. I'm going to put a arrow here. And I'm going to call this my y-axis. And I'm going to put an arrows on the x-axis. I got to scroll down. I'm going to keep it nice and big so we can see things for now. And later on, maybe I'll make it a little smaller. Okay. And I'm going to plot my first point, which is 0, 0. This is x here, and this is my y. Here's my x again if I want, right? So that's all along x, and this is all along y. And my point is right here. It's right at the origin, 0, 0. So we've done that one, okay? Now I'm going to scroll back up here, and I'm going to look at my table of values. So it's not working for me too good. So just give me patience here, and we'll get some other points. So if I did, for example, I don't want to do that. Oh. It's not being kind to me here. I apologize. So what I'm going to do, see if we can do this. I'm going to zoom out so that we can see things a little better. We can maybe see our grid and our numbers. Oh, it's going to be really hard for me to write in this small space, but I'm going to try it, okay? So if I look at here, I've got y equals x again, and if I put in 1 in for x, that means y equals 1 squared. Well, what's 1 times 1? That's 1. So that is a value here. That is the point 1, comma 1. And I can plot that point down here. X is 1, y is 1. And I can plot that point. It's going to disappear on me probably. Yep. There we go. 1, 1. Now I can also do over here on the side, I can do some more math. Hopefully this does seem to disappear, but that's okay. So I can say y equals 2. I'm going to select 2 squared. Well, what's 2 times 2? Well, that's 4. So I'm going to put in 4 here. All right. So now I have a point that is 2, comma 4. That means x is 2, y is 1, 2, 3, 4. and I can plot that point. So you can see here that I'm starting to get some points, but if you notice, it's not forming a straight line anymore. It's going to be a little bit crooked. And so 3, 3, I'm going to use the value of x equals 3 this time and see what we come up with. So y equals 3 squared. Well, that is 3 times 3 is 9. So I can put 9 in here, okay? And then I can do let's plot that, let's plot that point. 1, 2, 3, and then I got to count up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And then I can do one more. I can do 4. Let's do this. I go y equals 4 squared. Maybe you figured out the answer here already, but 4 squared is 16. And so that goes in here. And that is another point. Whoa, sorry, I apologize. I tapped the screen in the wrong place, so we'll get it back here. Whoops. Just wait for me to get her back. Here we go. Okay, so whoops, went too far. Just a second here. Okay, there we go. Okay, so 4, x equals 4. So 1, 2, 3, 4 for x, and 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And what we can also do is we can do the negative version of this. So now we're going to say y equals -1 squared. Well, what's -1 times -1? Well, guess what? It's 1, because 2 negatives makes a positive. And so we can continue to do this, and we can plot these points. X is -1, y is +1. So that point there goes onto my grid. Okay, then I have -2. Well, -2 times -2, that's 4. And we're starting to maybe see a pattern here. 1, 2, 1, 2, 3, 4. Okay, and then -3. Well, what's -3 times -3? When I put it in there, it is -9. So I go 3, 1, 2, 3, and I'm going to count all the way up to 9, and I'm going to plot a point there. Of course, it's going to disappear on me. I can tell that it doesn't like it sometimes. And then the last one is, well, so that would have been 9, and then the last one is -4 squared, which is 16. Okay, and so you'll see that the numbers going across here for x are the same on either side, but or for y, sorry, the numbers are the same on either side of 0. Okay, and then what we do here is go -4 all the way up to 16, and I'll plot the points. Now I have a whole series of points here, and I want to create a curve. Now, technically, what I would do is I would draw this by freehand, and this is really challenging here to draw it by freehand, but I'm going to try it. Ooh, look at that. I didn't do too bad. And I would draw it like this. And this is what we refer to as a parabola. Okay. This shape is a quadratics parabola. So we call that a parabola. Okay. And it's not a linear equation. It's a parabolic equation. Okay. Now I can draw this as well using the computer tool. Watch how I do this with the computer tool, so it can be really clean and neat. Okay, so I can use a special tool, this one here, and I can actually click on the individual points and just drag the line around, and so I go from one point to here. Right now that would be linear, and then as I go like this, it curves, and I keep clicking on each of the points as I go, and I'm going to go like this, and I'm going to go like this, and I'm going to go like that, and I'm going to go like that. And whoa, I got to get rid of it now. and I hit the escape button and it takes it away, and I actually have the line drawn there. Now I'm gonna make that line a little thicker. I'm gonna do that is I'm gonna first make it black, and then I'm gonna format it. See if it'll let me format the. It's not letting me. See if I can erase some of my pen here. I'm going to try to erase some of my pen here. So there you go. You can see as I erase my pen, you can see that nice curved line that's coming along, which is really good, right? It just shows a really nice line that swings around. And that's what a parabola really looks like. Technically, to finish this, I always should include, just like with a line, a couple of arrows on either end going, in this case, pointing up. And this is your most basic parabola, okay? Now, before I end, I want to explain another thing here that exists, and this is a standard, all standard parabolas have this, and it's called the step values, okay? And I've written them in here as steps, okay? But we often refer to them as step values. And what I'm doing is I'm saying, as x goes up by 1, 2, 3, and 4, which are the values we pick, what happens to y? Well, it went from 0 to 1. What's the difference between 0 and 1? Well, that is a difference of 1. I think most of you can see that, right? 0 to 1. What was my step value from 0, for the next one, from 1 to 4? How much did we increase to go from 1 to 4? Well, we increased by 3. So I'm going to put my step here as 3. Then I went from 4 to 9. What did I increase to go from 4 to 9? Oh, my step value was 5, right? And the last one, well, maybe you see a pattern. Can you see a pattern? 1 to 3, 3 to 5. What do you think this step value will be? Well, 9 goes to 16. The step value is 7. Maybe you can recognize the next step value would be 1, 3, 5, 7. You got it. It would be 9. And then 11. And keep going, 13, 15, and so forth. And you might say to me, well, why do you care about that? I mean, this seems so silly, right? Well, we refer to this point right here, the point where the parabola kind of comes down and turns around. We call this the vertex. And in this particular case, the vertex is 0, 0. Okay, it's the origin of the graph, real simple place. And we can use our step values to help us graph really simply. So what we do is we go over 1 always. And what's our first step? 1. So over 1, step up 1. Then we go over 1 and we step up 3. Over 1, 1, 2, 3. Then we step up 5. Over 1, step 1, 2, 3, 4, 5. Oh, hopefully you're liking this. Over 1, step up 7. 1, 2, 3, 4, 5, 6, 7. And we could go over 1 and step up 9, and then over 1 and step up 11, and the graph would just keep going up and up and up and up and up and up, and it'd get really, really steep. And the same process occurs on the negative side. Over 1, up 1. Over 1, up 3. For some reason, we're missing that point there. Over 1, up 5. 1, 2, 3, 4, 5. Over 1, up 7. 1, 2, 3, 4, 5, 6, 7. And that creates our parabolic shape. So we use the step values, and you'll notice that the step values here are 1, 3, 5, and 7 again, because that's the difference between 0 and 1 is 1. The difference between 1 and 4 is 3. The difference from 4 to 5 4 to 9, sorry, is 5. And the difference from 9 to 16 is 7. And that creates our wonderful thing known as our step values, okay? So in this particular case, if I tell you where the vertex is, you can easily graph a line. You simply just start with the vertex and then go over 1, up 3, over 1, up 5, over 1, up 7, over 1, up 9. Okay, so let's just do an example like that. I'll simply take. I'm going to escape here. I'm going to add one little quick example here. Well, no, that's not going to work. I'm going to leave you to kind of play with that as part of your homework. If I was to move the vertex, let's say, well, let's just do it on this page. I don't know why I'm being silly. Let's just do one on this page. Let's say the vertex is going to be right here. I don't even care what that is, but it is, I don't know, 1, 2, 3, 4, 5, 6, and 1, 2, 3. I can go over 1, up 1, over 1, up 1 on this side, over 1, up 3, 1, 2, 3, and over 1, 1, 2, 3. I can go over 1, 1, 2, 3, 4, 5. I'm in the middle of my parabola word, and then over 1, up 5. 1, 2, 3, 4, 5. And now I have a few points here. I'm just going to put that point back in, and I can draw my graph. And you're going to just draw it with your hand, okay? You're just going to freehand draw it. Like, you're not going to have this beautiful curve like I did with the computer. You're just going to go like this and try to go through all the points and turn and go up like that, arrow on each end. And there you have it. That is a parabola. And the vertex in this case is 6, 3. We just write V for vertex because we're lazy, we're math people, okay? And there's my vertex 6, 3. So when I give you your homework and I say, draw me a parabola that has, has a vertex of, 6, 3, then you would draw this parabola like this. A standard parabola, I call it, just your standard parabola, okay? And the very basic standard one starts at 0, 0, okay? So it's pretty straightforward stuff, okay? I'm not asking for rocket science here. I think you can handle doing this basic parabola. All right, try your homework, and a few questions there for you to identify linear, parabolic, or quadratic, and circular equations, and then drawing a few graphs. One will be the vertex and using the step values, okay? It's really important that you get used to using step values, and hopefully that helps you. Thank you.